In the graph below, triangle ABC has coordinates a negative 9, 2, B is negative 6, negative 6, C is negative 3, negative 2, and RST has coordinates of R negative 2, 9, S 5, 6, and T is 2, 3. Is triangle ABC congruent to triangle RST? Use the properties of rigid motions to explain your reasoning. So one of the properties of rigid motions is that rigid motions is supposed to preserve side lengths as well as angles, right? Because we're working on a coordinate grid, we don't typically show angle measures are the same on a coordinate grid, at least not in Regents Geometry. So we don't have to go down that route. What we do need to take into account is whether or not the distances are preserved. So looking at this right now, let's take a look at. We're trying to show whether or not ABC is congruent to triangle RST. So if that's the case, then AB should correspond with RS. BC should correspond with ST. AC should correspond with RT. Let's find the lengths of all these to see whether or not the lengths are actually preserved, right? So looking at AB, let's see here. From A to B, I go down 2, 4, 6, 8, and then I go over 3. So AB has a length of 8 squared plus 3 squared. So that would be square root of 69. So that's the length of AB, right? So AB is square root of 69. Let's find the length of BC. So I go 3 over and 4 up. So BC will be 5, right? How do I know that? Well, that's because square root of 3 squared plus 4 squared, that's a Pythagorean triple, right? So 3 squared is 9 plus 4 squared is 16. So 9 and 16 together is 25. Square root of 25 is 5. Okay, and then we're going to again find out what is the length of AC. So we're going to go over 2, 4, 6, and then we're going to go down to 4. So this would be square root of 6 squared plus 4 squared. 6 squared is 36. 4 squared is 16. That would be 52. This would be square root of 52. So AC is the square root of 52. Now let's try to come up with the side lengths of the other triangle there. So I have AB, BC, and AC figured out. So now I want to figure out RS, and then ST, and then RT. Okay, so RS. So we're going to go 2, 4, 6, 7, and then down 3. So 7 squared plus 3 squared. That would be the square root of 7 squared is 49 plus 9. That would be 58. So immediately, right, I already see RS is equal to square root of 58, which is different from square root of 69. ST, we're going to go 2, 3, and 3 up. So this is going to be square root of 3 squared plus 3 squared, which is square root of 18, which is again different from 5. And lastly, let's find out RT here. We're going to go 2, 4, 6, and then over 4. So this is the square root of 6 squared plus 4 squared. So that would be the square root of 52. So RT is the only one that has its length preserved. So here, since AB is not the same as RS, BC is not the same as ST, distances is not preserved. There is no rigid motion to map ABC, triangle ABC, onto triangle RST. ABC triangle ABC is not congruent to triangle RST.